Hello students, welcome back to geometry. Today we're going to be introducing some special parallelograms. Now before we get into the special parallelograms, I want to take a moment to talk about what a parallelogram is. So a parallelogram is shape that looks like that. Oh, I thought I had this activated. There we go. So in a parallelogram, we have a couple of key features that we talked about in previous lessons. The first thing is the opposite sides are congruent. The second thing is the opposite angles are congruent. The third thing was that the diagonals bisect each other. So that means that these are congruent and these are congruent, but not necessarily congruent to each other. And of course, the base definition of a parallelogram is that the opposite sides are parallel to each other. Now, as we talk about special parallelograms, the special parallelograms are parallelograms, so all of these properties apply to the special parallelograms. So, let's start off by talking about a rhombus. And a rhombus is a parallelogram where all of the sides are congruent. Now, every year that I talk about this, there's always one person who says, no, that's not a rhombus, that's a square. Actually, a square is a rhombus, but not all rhombi are square. So, for example, if you take a square and just pull on two of the corners, what we get is a parallelogram that looks like this. So you see, this is definitely not a square. However, all four of the sides are congruent. Now, there are two things that are special about a rhombus, and they both have to deal with the diagonals. So, first of all, let me draw one of the diagonals in. So, hopefully you see I've created two triangles right here. And since this pink line right here is a part of both triangles, I've actually created two congruent triangles using side, side, side. Since those triangles are congruent, their corresponding pieces must be congruent using CP/CTC. So that means that this angle is congruent to this angle. Notice it's an isosceles triangle, so the base angles are congruent. And then this angle would be congruent to this angle. They're congruent to each other. So what we have here is this diagonal cuts straight down the middle, and it creates these four congruent angles. So what we have here is a line that splits an angle exactly in half, which we call a bisector. So that means that this pink line right here is cutting those angles exactly in half. That pink line is an angle bisector. And hopefully you see too that if I do the other one, we would be able to do the same thing. So that means that both of these are angle bisectors. So let me write that down there. The diagonals of a rhombus bisect the angles that they intersect. Now, another thing that we notice about the angles of a rhombus is if we look at this closer now, we'll notice that we've split it up into 4 triangles. But those 4 triangles each have this pink angle and this green angle and this orange side, which means all 4 of these triangles are congruent by angle side angle. Now, if all 4 of those triangles are congruent, that means that all of the pieces have to be congruent, which leads us to this interesting fact about the third angle. This third angle is congruent all the way around. So, if I have all 4 of those angles are congruent and all 4 of them go around to make a full 360 degree angle, that means each of those angles has to be 90 degrees. So I'm going to erase these marks right here, and I'm going to replace it with the proper symbol, like that. So a simpler way of putting that is the diagonals of a rhombus are perpendicular. And that is our first special parallelogram. So if we say rhombus, it means that all 4 of the sides are congruent. And the 2 things that we need to know about the diagonals are that the diagonals of the rhombus bisect the angles that they intersect, and the diagonals of the rhombus are perpendicular. Okay, now we're going to visit a shape that we've known since elementary school, a rectangle. So a rectangle is a parallelogram where all of the angles are congruent. So, this is going to feel a little odd because I know that your elementary school definition of a rectangle is it's like a square but it's long and it's got 4 right angles, and those are all true. But let's go ahead and draw a rectangle, and instead of thinking of your elementary school definition, think of a parallelogram but where all of the angles are the same. Well, a parallelogram is a quadrilateral, and all quadrilaterals have interior angles that add up to 360. So if all 4 angles in this quadrilateral are the same, they would each have to be 90. So that is what a rectangle is. Now, for a rectangle, we have the diagonals, and I'm going to go ahead and just copy this. And I'm going to make another one so I can draw the diagonals in. So I have a diagonal here, and then I have another diagonal here. And there are some interesting things that happen with that. And I'm just going to split them apart so you can see the 2 triangles. So I have this red triangle here and this green triangle here. So those are each of the 2 different diagonals. But one of the things that we notice is that since it's a parallelogram, opposite sides are congruent. So that means that these 2 sides are congruent. Also, using the reflexive property, the bottom of both of these triangles, the base, is also congruent by the reflexive property. This leads us to show that these 2 triangles are congruent by using side angle side. Since the two triangles are congruent using CPCTC, I know that this side has to be congruent. And this leads us to the one big thing about rectangles, is that the diagonals of a rectangle are congruent. Now, since a rectangle is a parallelogram, I also know that the diagonals bisect each other. So if I have two congruent diagonals and they also cut each other in half, that means in a rectangle, all four of these pieces are congruent. So, that leads us to a very special parallelogram, a square. And a square is really interesting because a square is a parallelogram that is a rectangle and a rhombus. So a square is a parallelogram where all four angles are the same and all four sides are the same. So if I draw a square, that means that all four sides are the same and all four angles are the same. But what does that mean about the diagonals of the square? Well, if I draw the diagonals of a square, the first thing is, if it's a rhombus, that means that the diagonals are perpendicular to each other. So all four of these angles in the middle are all 90 degrees. Since it's a rhombus, that means that it cuts all of these angles in half, but those angles are congruent since they're a rectangle, so that means every angle right here is exactly 45 degrees. And then since it's a rectangle, the diagonals are congruent to each other, which means all four of these little pieces are also congruent. So basically we don't need to add a special definition of a square. All you need to know is that all of the properties of parallelogram, rectangle, and rhombus all apply to a square. So let's do a few examples. Let's solve for all of these given that this parallelogram is a rhombus. Cut off the directions there. All you need to know is that we're looking for angles 1, 2, 3, and 4 because it's a rhombus. So first thing that I know is that angle 1 has to be 90. Angle 1 has to be 90 because it's a rhombus and the diagonals are perpendicular. The second thing that I know is that the diagonals bisect each other, so that means if this is 61, this is also 61. Since a rhombus is a parallelogram, opposite angles are congruent, and also opposite angles are getting bisected by the diagonal, so that means that 2 and 3 are also 61. Now, I have to use the triangle sum theorem here. All angles of a triangle are going to add up to 180 degrees. So I know I've got 90, and then 61, and then angle number 4 right here. So I can say A plus B plus C is equal to 180. And I can say A plus 90 plus 61 equals 180. This would be A plus 151 equals 180. And then I'll subtract 151. Get A is equal to 29 degrees. So that means angle 4 over here is 29 degrees. Okay, so in this case, this shape is also a rhombus. Since I know this is a parallelogram, these two sides are going to be parallel, and then I've got a transversal going across the bottom. So this is 118 degrees. This angle right here would form a pair of consecutive interior angles, which means these two angles would be supplementary. So if this angle is 118, that means this angle right here has to be 62. That way they'll add up to 180. But if angle GFE is 62, and if this is a rhombus, I know that that diagonal is going to cut that angle in half. So 62 divided by 2 is 31. I know that each of these angles is 31. And then since it's a parallelogram, the opposite angles are congruent, and they're also being bisected, so each of these is 31 as well. Okay, so in this rectangle QRST, QS is equal to 5x minus 31, and RT is 2x plus 11. Find the lengths of the diagonals of QRST. Well, I know that QS and RT are the diagonals, and I know that in a rectangle the diagonals are congruent, so I can just say 5x minus 31 is equal to 2x plus 11. And then I can solve that. So I'm going to subtract 2x on both sides. Now we'll get 3x minus 31 is equal to 11. We'll add 31 on both sides. We'll get 3x is equal to 42. Dividing by 3, we get x is equal to 14. Now paying attention, it says find the lengths of the diagonals. So I would plug this in. I like this one better. The numbers are smaller here. So RT is equal to 2 times 14 plus 11. So that would be 28 plus 11, which is 39. Then I can answer in Word. Each of the diagonals is 39 units long.